Okay, so my name is Mr. Ben, and I am from the Children's Museum at Saratoga. I'm very happy to be here with you today, and today we are going to be discussing magic versus science. So before we dive into all the really cool things that I have to do today, we need to figure out what exactly is magic, what exactly is science. Now, science is something that we study in school, so it's the way that we understand the world, generally speaking. Science is pretty deep as far as how much you can talk about it, but just as a quick generic idea, it's how we learn and understand the world around us. Now, however, magic is also something that we use to try and understand the world around us. So let's take a quick look at my board right here. So I got magic versus science, and on it, it says, what is magic? Now, I paraphrased the definition that I found on the internet, but basically, it's the influence of the physical world through mysterious supernatural means, okay? So the really important things is this mysterious and supernatural, okay? So a lot of times magic replaces science because we don't understand what's going on. And because we don't, you can either A, admit that you have an ignorance to something, or you can decide that there is something mysterious going on, and you could even kind of imagine what it is that it could be. And then supernatural is by definition, if we take a look down here, magic defies the laws of physics, okay? So anything that is supernatural, meaning it's outside of nature, automatically defies the laws of physics, okay? So we want to keep that in mind. We want to keep that in mind throughout the entire program, because we're going to be kind of exploring whether or not we're looking at magic or whether we're looking at science, okay? So to start, I want to talk a little bit about mixing things together, because a lot of times when you have an occurrence, it's when you have two things that have been apart and you pull them together and they mix and then something happens. Now, a lot of times when you mix things together, they remain separate, so to speak. So for instance, if I take a handful of blue beads and I take a handful of red beads and I put them into a pot, right? I have my pot full of red and blue beads, but if I so choose, if I want to put in the energy, I can pick out each one of the red beads and put it back into this bowl. And then I can pick out each one of the blue beads and put it back into this bowl, and I can separate them apart. See, when I mix these things together, they are still distinct from each other. There's nothing that's happened to any of the blue beads or any of the red beads that have changed them, okay? However, when we mix things together and we have some kind of magical occurrence, you're often looking at something that changes its state. It turns into something else. You end up with different things out of it than what you put into it, okay? Now, if you don't understand that, you can attribute that to some kind of mysterious and supernatural force and say, I don't know. It could be fairy, it could be magic. Or you can investigate the properties of what you have and do a scientific investigation to find out, well, what is going on here? Why are these things occurring? Why have I had this result? And that's part of the scientific process, to ask questions, to do a little bit of research about what it is that you're curious about, to formulate a hypothesis as to what you think will happen. Then you conduct your experiment, and then you analyze your results and go, well, does this match with my hypothesis? Why does it match with my hypothesis? Why doesn't it match with my hypothesis? And then you conduct the experiment several more times, either to extra confirm your hypothesis or to realize that my hypothesis did not work, which is an educated guess, realistically. Or do I have to kind of look at this in a different way? And so this is something that scientists do. So the first thing I wanted to do is I wanted to mix a couple things together, and I wanted to see what happens with them. Okay, so we're going to start with just a humble little beaker right here. That's going to be our receptacle. That's going to hold all of this stuff. Now, I want to start by using magic. Okay, so the first liquid that I can think of that doesn't really have an effect on many things is the most common liquid that we deal with every day is water. Now, chemically speaking, water is actually very reactive, but most of the stuff that we deal with on a daily basis, water is not very reactive. So we can drink it, we can put it on things, we can use it to clean stuff, and it just remains water. It doesn't interact with other things. Okay, so if we want something to happen that involves water, at least in this experiment, we're going to need a little bit of magic. Okay, so I'm going to start by putting the water that I have right here into this. Now, I anticipate a mess out of this, and if you're doing this at home with me, you're going to also want to anticipate a mess. So we're going to start out with a beaker full or a bowl or whatever you're using if you're doing this at home, full of water. Okay, so water is really boring. It's not going to look very nice. So I want to add something that's going to highlight our little experiment here. So I've chosen to use a paint color. Any color will do, but this just makes it a little bit more interesting. So I'm going to put a few drops of that in here. Okay, all right. And I'll grab myself a little spoon. And if you take a look real quick, this is something that's really cool. You can probably see, I don't know how close I can get, but you can see that the liquids, they haven't started mixing yet, or they haven't mixed all the way through. You can see these swirls in there. And you can see it slowly mixing. Well, you see, we think of things as being stationary, like this water is sitting still. But realistically, it's not sitting still. Nothing is sitting still. Everything is moving at all times. Now you're saying to yourself, but this wall behind me is not moving. This table is not moving. And that's because a lot of the movement is at a molecular level. So it's down at the deep roots, the things that we can't see that make up everything, the matter of everything. So these are the molecules and the atoms that come together. So even though this water appears to be still, the little molecules of water are moving all around. Now, as a solid, they move a lot less. As a liquid, they move more. When we move into gases and plasma, they start moving around a lot more. So if I just let this sit here for long enough, these will mix together all on their own because of that molecular movement. So that is something you could say, well, how is it moving around? It's still, it could be magic. But if we look at the molecular level, if we understand what's going on, we know that it's science. It's science that is pulling this together. Okay, so the next thing that I want to add is something that's going to, it's going to add a little bit to this. We'll talk about why we're adding this before, but you're probably familiar with this. It might not be the color you're used to, depending on what you get, but this is just dish detergent. So we use that to help clean things up because of the way that soap works. It allows us to grab onto things that don't normally dissolve in water, and the soap can grab it and pull it in like grease. Grease and water don't mix, but soap allows them to mix together because of the molecule that's made of. One part of it says, ooh, I like oil. The other part of it says, ooh, I like water. And water and oil are like, I don't want to be together, but the soap says, let's come together. So that's how you're able to clean your dishes. So we're going to add a little bit of soap to this. And again, we'll explain why at the end as we're moving through. Okay. So let me get that mixed up here. Okay. All right, so now we're going to add the last part. This is the reagent. This is the part that is going to theoretically cause our reaction, cause the thing to happen. Now, first, as I said before, I want to use magic. So I'm going to cast the magic spell. And if you can do this with me, I know that you might not say the same magic words that I do, but I'm going to guess that your magic is just as strong or maybe even stronger than my own. And so if you want to say your own magic incantation as we do this, you can go right ahead. So, abracadabra and alakazoo, turn this into witch's brew. Okay, so if the magic works, then when I add this in, it should cause something to happen, all right? And 3, 2, 1, and nothing. So we're taking a look here. I'm waiting, maybe it's a delayed reaction. Sometimes that occurs. But I'm not seeing anything happen here. So, well, let's go back to the drawing board, all right? So we're going to ditch this, and we're going to try this experiment again, but this time, we're going to add something that I know is going to help us out. So, I used water to start with. Now, again, as I said, water is reactive as a chemical, and just keep in mind, when somebody says chemicals, a lot of times we think of things like something that's under the sink that's dangerous, and those things are dangerous if they're mishandled, but pretty much everything is a chemical. So water is itself a chemical, and it is reactive, but again, in our day-to-day lives, water isn't that reactive. But let's grab something different. Now, you're probably familiar with this. This is just some vinegar. Okay? You might use it for cooking, and you can also use it for cleaning. Well, this is an acid. So if you're unfamiliar with the concept of acid and bases, you'll learn more about that. But basically, water is somewhere in the middle. It's neutral. It doesn't really react in this way. But as you get some changes in your water, you add some things, what you do is you have a separation of the water. The water kind of splits. And one part of it, which is positive, goes over here, and the other part that's negative goes over here. Now, when you have just pure water, they're going to be equal, and so they're neutral. But if you add other substances and get an excess of the positive or an excess of the negative, you're going to end up with an acid or a base. Now, because acids have something that bases don't in excess, and bases have something that acids don't in excess, when they come together, they tend to go, hey, you have something I need, and they try and combine it. So, as I said before, when we have a mixture, we can put those things together and we can separate them. When we had our pink liquid before, it would be very energy intensive, but I could separate those out and I could get my pink dye back, I could get my baking soda back, I could get my soap back, and I could get my water back all separated. Again, the amount of energy I have to put in to do that would be ridiculous, but it is theoretically possible. However, if I have a chemical reaction, no amount of me separating them will get me back what I started with because they have fundamentally changed. So let's start out with our acid, our vinegar. We're gonna put quite a bit of it in here. Okay, so we're gonna go through all the same steps that we would before, because in a scientific experiment, you only want to change one factor, because if you change too many things, well, you don't know which thing was the thing that had the different effect. So if I change two things and I have a different outcome, well, which one of those two things? So we're just going to change the liquid that we're using. We're putting in vinegar. So let's start out. We'll add our coloring agent. Now, because vinegar is mostly water, it's still going to act the same. So you can see that we have the same diffusion going on. There's still the molecules moving around, and it's mixing this slowly together, not as quickly as I want, but it is still doing it. Okay. So we're going to add in our soap. Make sure that's all good. We mix it together. All right. And so now, if my hypothesis is correct, and I go, well, this is an acid, and this, our baking soda right here, is a base. Now, bases and acids tend not to react unless they're in an aqueous solution, meaning that they're in water. So the acetic acid is inside of water, which allows it to move around. And once I add this into the liquid, it's going to mix in and hopefully cause a reaction. All right. So here we go. And 3, 2, 1. And so you can see that we definitely have something different going on here. Let me add a little bit more of this in there. And so you can see that unlike our water reaction, or lack thereof, we definitely have something going on here. We're foaming out, so something is taking place. Something has changed. I no longer have vinegar and baking soda. I have something new. So the water in here that pulls everything together allows it to mix, and what you're getting is you're having our vinegar friend here and our baking soda friend here. They're giving up that thing that they have extra. You have your extra hydrogen molecules in here. You have your extra hydroxyl groups. And now they're coming together and they're making water. So they're forming water, more water, and they're also creating a salt. Any acid-base reaction is going to give you a salt. Sometimes it's like table salt, but there are many different salts, and that's when you have a metal, which is on the far side of the periodic table, which would be on this side if you were looking at me. And when you have a non-metal on the other side, they come together, and they have this reaction. So you can see we have this nice foaming mess, and good thing I put a very large receptacle down there, otherwise I would have a huge mess on me. And let me just move that off to the side there. So before we move on, does anybody have any questions, any comments, any concerns, stories, anecdotes, tall tales, or requisitional forms?
I have a question. So, just to confirm, how does the foam form?
Good question. So remember the different parts that we had, right? We had the vinegar, which was our base, and water before. We added this, and I talked a lot about how the reaction had to do with the baking soda, but we haven't addressed this guy right here. So if you remember, this is soap, and what is soap very well known for making? If you splash it around a little bit, or maybe
Foam? Or bubbles?
Bubbles, absolutely. Now, what do you need to make a bubble? You need something inside of that bubble, something to push an outward pressure in order to maintain that membrane. What do you need inside of there?
Air?
You need air, you need a gas. So we talked about two of the products that we made. We made water and we made a salt, but also we made a gas. In this instance, we made carbon dioxide. So that's the stuff that you breathe out. So you breathe in oxygen and a lot of nitrogen. There's mostly nitrogen in the air, but you breathe in your oxygen. That goes into your lungs. Some of the oxygen gets moved around and moved into your system, and then most of it actually comes back out. That's why we can do CPR, because your lungs aren't super efficient. They only gather, I think it's 20% of the oxygen, and so 80% of it comes back out. That's why we can do CPR, because there's oxygen left in our breath. But there is a conversion of some of that oxygen is used to take some of the carbon. That's like the food that we take in, there's carbon in that food. And so as part of the whole process, some of that carbon is released on some of that oxygen that is coming to our body. Okay, so we made a gas here, and we're going to really show that in our next experiment. Okay, do I have any more questions before I move on to the next one? That was a good question. That was a really good question. All right, so we're actually going to go to the exact. Oh, can I hear somebody?
When I tried mine, it went really slowly.
Yeah, so reactions go based on, sometimes it's the surface area, it's also the reactivity. So when you have smaller molecules that work faster, if I had stirred mine up, it would have reacted a lot faster. I wanted it to kind of go slow to give me a chance to talk to you guys. So if you want to speed up a reaction, you can add some heat energy. You can make those molecules move faster, because remember, even though this vinegar, this water is still, those molecules are moving. Well, if you add heat energy, you're adding kinetic energy to the molecules. You're adding motion to the individual pieces. So if you start getting them to move faster, that means they'll react much more quickly. So if you have a slow reaction, add a little bit of heat. All right. So we're going to show that there is a gas in here. So that's what the soap was for. The soap was to grab that gas and just add that little extra oomph to our experiment, okay? So again, we're gonna do the exact same experiment, but we're gonna watch how this occurs. So I'm gonna take my vinegar, because I've now learned that water doesn't work. And I'm starting to question whether or not magic is possible. So I'm gonna add my vinegar into here. This is my acid. A nice amount there. So, in any balloon, what are we adding to a balloon in order to get it to work the way that we want it to? We need to add air, a gas. So typically we're either going to blow it up with our mouth, or we might have a little gas tank that has helium, a different form of gas, or something else. And so what we're going to do is we're going to try and get the gas that came from this reaction that we're going to capture in here to blow up this balloon. Okay. Now, the interesting thing about gas is when you have a solid retains its shape, it retains its form, it retains its size. So if I have this table and I pick it up and I move it over there, it's going to stay the same size as the table. It's not going to change at all because of the way the molecules are there together. when you have a liquid, what you've done is you retain your volume, so the amount of liquid is always the same and will always take up the same amount of space, but you've lost a definitive shape because a liquid will take up whatever shape your receptacle is. So if I put it into a bottle, it will become the shape of the bottle. If I put it on the floor, it will spread out as far as it can, and it will become a puddle. If I put it back into a cup and I get every last drop, I will have the same amount of water. It will fill up the jar the same amount, but it will again take the other shape. And then when you get a gas, you've actually lost your volume as well as your form. So obviously gas doesn't have a form of its own, but the important thing is that gas can expand and compress. Liquids and solids aren't compressible to a degree. There is a certain amount of give that they will have, but those molecules are already tightly packed together. So there's not a lot of room for them to move. A lot of times when you do manage to crush something, you're actually displacing things, or you're taking up space that you didn't realize was there, okay? So now that we have this, and I have a huge mess, we can check out to see how this gas works. Now, the gas, because it doesn't have a definitive volume, it can push or be pushed on. So the way the balloons work is that they have a non-rigid wall, which if enough force is exerted on them, they will start to expand. So in theory, I should be able to, just like in our experiment over here, I should be able to dump this in and I will get a similar type of effect. So here we go. All right. Oh, guess not all of it got in there. There we go. So you can see, there we go. I have my reaction going. You can see it kind of bubbling in there. And it's blowing up my balloon. It's putting that carbon dioxide gas, the gas that is being created from our reaction, it's putting it into this balloon and allowing it to expand, okay? So you can see that the reaction has kind of died down. I've used up all my components. All right, so either I've run out of baking soda, which is most likely the case. I've run out of enough baking soda. If I had the ability, I could add some more and it would continue this reaction. But so we can see clearly that we have caught a gas. Just like with our bubbles, we've allowed the gas to get trapped. So we've combined a liquid and a solid, and we have a chemical reaction where we get a gas. We have extra water. Water's been created. There's a salt in there that I could pull out if I wanted to apply the energy to it. And then I've captured the gas inside of here. And if I had a spectrometer or if I had some other way of analyzing it, I could find out that I am indeed correct that this is carbon dioxide gas. So there's that. All right. Are there any questions, comments, concerns about that little part of our experiment? I think somebody has their hand up. Maybe, no, that's just the background thing. All right. Okay, quickly get this all cleaned up. All right, so right now, just kind of give me an idea. Who here thinks that so far anything that I've done has to do with magic? Raise your hand if you think.
I have a question.
Oh yeah, go ahead.
I already know this science experiment that we did now.
Oh, very nice. It is a common experiment. But just in case anybody hadn't experienced it, I wanted to make sure that they saw it firsthand, because science is about gaining what's called empirical data, or data that you can analyze, that you can touch, feel, and you can do that research on. So I could tell everybody, oh, just believe me, this is how it works. But seeing is believing, and allows you to actually experience and understand that. And hopefully, if you're inclined, if you're curious, you can do these at home. Most of the stuff that I have available here is stuff that you can get out of your kitchen and allows you to do that at home. So I encourage you all to experiment. All right, so let's move on to the next thing. Okay. So this last one, or maybe second to last one, is also an acid-base reaction. But I'm going to demonstrate something a little bit different, and this will look a little bit like magic. Okay, so right here, instead of the vinegar, I'm going to be using these citric acid crystals. So they come in a solid form, which is really convenient for me. There's the little label up top. It's really convenient for me because just like the baking soda right here, which is in a powder form, it's easy to transport. It doesn't weigh a lot. And I can just add water to it to get those ions, to get that the hydrogen ion and to get the hydroxide ions to my place. Okay. So we will start by getting our solutions, because again, acids and bases don't really react when you have them in a powder form. And we can actually demonstrate that by, I'll just put a little bit, make sure you can see it. I'll put a little bit of this here, and I'll put a little bit of this here, and you can clearly see that nothing has happened. I put my acid and my base together, and absolutely nothing has happened. They can't exchange anything because there is nothing to exchange there. Okay? So I put my baking soda in this one, and now I'm going to put my citric acid crystals in this one. All right, and in order for my experiment to be conducted, I need to put them into an aqueous solution. So I need to add water and mix them together. So, that about halfway. We'll get this one here. And make sure we're using clean spoons so we don't accidentally get a reaction. You always got to make sure when you're conducting science experiments that you don't have any cross-contamination. Because if you do, it's going to ruin your experiment or give you results that you didn't anticipate. Okay? Now, we'll give them a moment to settle because right now you can see that this one is kind of cloudy, but you can see through it, so you can kind of see everything that's behind it. Oh no, that wasn't it. You can kind of see stuff through it. And then we have our citric acid, which is actually pretty clear. There's a couple little bits at the bottom, but you know, slowly the energy of the movement of the water molecules will mix us together. Okay, so now I need the last part. This is the part that is going to appear to be the magical element that we're adding. So this is some red cabbage powder. It's really cool, especially with what we're going to do. And I only need just a very little bit right in here. And we got extra water right over here. I'm going to get this into aqueous solution as well. All right, so I know it might seem obvious, but I want to ask the entire class, what color is this liquid? And I'll stand in front of it so it's a little, I guess that doesn't make any difference. What color does this appear to be?
Red.
It could look a little bit red.
Pink.
Kind of
Purple.
a little bit purple. I can definitely understand through a video camera it might not look as good, but it's a dark color for sure, right?
Yeah.
A dark whatever color it is. To me, it looks a little bit purple. You might see it as red. But it is a dark color. Okay.
Dark
So,
red and purple.
yeah, it's kind of a reddish purple. So here is our baking soda. What color is this?
Like kind of clear-ish, kind of hazy, a little gray.
Yeah, it's mostly clear. It's hazy. That's just because the particles, the baking soda particles, are really, really small, so they suspend really easily. They will eventually settle out. I put too much for the amount of water that I'm in here, so it's not dissolving. So this is my base. Okay. And then here's my acid, my citric acid crystals. And what color is this?
Transparent.
Yeah, it's completely transparent, okay? So when I put my purplish reddish liquid into either one of these, what do you think the result is going to be? What should I theoretically expect out of my experiment? What if I combine clear and purple, what do you think is going to come out of that?
The purple might become lighter.
Okay, so we're going to dilute it. We're going to add more water to the amount of particles there, so it should become lighter. Just like if you add water to any colored liquid, it's going to slowly diffuse it out and make it a little bit lighter. Okay, so that's theoretically what should happen. If I just, and I mean I could take this quick little bit of water here, and I put it in here. So if I do it with just regular old water, we can now see it looks a little bit more purple here. And it's definitely lighter than the liquid here. So that is a good theory of what can happen, right? So let's see what does actually happen. Let's start out with our base. Okay. And since this isn't going to be too messy, we can put it right up here. All right. Make sure my hand's out of the way. I want you guys to get the full view. All right, so what color do we have?
Light purple.
Let's see, let's add a little bit more.
A little darker now.
Indigo. Purple.
Yeah, so it's kind of an indigo, it's kind of a, I would dare say, well, let's compare it to our water.
Violet.
It's a lot lighter than that.
Yeah, it's more of a blue color than this one. This one is definitely kind of a purple, but this one has a very blue tint. But we didn't have any other color in here. How can purple turn into blue? That doesn't make any
Because
sense.
the lighter it gets, the more it looks like blue.
Well, I mean, this is lighter, but this is still pretty purple. I could add a little bit more water to this. Take a quick look. Oh, there was contamination in that, so that didn't work out. Okay. All right, let's see what happens when I grab, there's my other one. Let's see what happens when I do it to this one. Yep. So what do we have here?
It's like reddish orange.
Yeah, red. I'd say it's orange.
Yeah, it definitely looks orange on the screen. It looks a little bit more pink in reality, but yeah, I can see in the window there. It definitely does. So, but wait. I put the same liquid. I put this same liquid into these cups, and I got a different result with just plain water as I did with my acid and my base. So do we have an instance of magic? Have we created magic? Have we defied the laws of physics? Who thinks so? All right. So what we have done here is we have used what's called a universal indicator, all right? So an indicator is something that changes color in the presence of certain other substances. In this case, we're talking about our acids and bases, okay? Now, when we have a base, we're going to get our blue color here, and when we have an acid, we're going to get a kind of orangish or reddish or pinkish color, okay? That is something that we use to determine whether things are acids or bases. Now, so, okay, so let's start to think about this, okay? Now, what do you guys think is going to happen when I take these two liquids and I put them into this receptacle together at the same time? What do you think is going to happen? Yes. Let's see.
It can become lighter.
It could get lighter, absolutely. Let's see. Sorry if I said that wrong.
It'll get the same color as it was before when it wasn't mixed with something.
Okay, so you're saying that the color that it came out of here, it's going to turn back into that color?
Yeah.
Okay, why do you think that? What do you think is happening at the molecular level? What do you think is going on there?
Because those two colors like make up like the color with like when you put the red powder in it, like those two liquids like make up that color.
Okay, so you are looking at it as a color thing. If you put these two colors together, a blue and a red should come together to form a purple. That is absolutely logical, okay? Does anybody else have any other thoughts as to what will happen when we put that together? I want to get as many ideas, as many hypotheses as I can. Does anybody else?
Maybe. So I think I could agree with because what you said, if you had like with the bead example, if you had like the energy to take the beads apart, it could be the same thing with that. If you put them back together, they could separate molecularly.
Okay, I like the thought process there. So you're saying that, you know, energy will be put into this and that will allow it to separate. Okay, all right. Does anybody have any other thoughts as to what might happen when I put these two together? Okay, we'll proceed. Oh, go ahead.
I think that since the red is a little lighter than the purplish color, maybe like since one is purplish and another one is like orange or red, I think it's gonna become green or like yellow.
Okay, okay, all right. And lastly, is that all that you think will happen? Just it'll change back. All right. Oh.
Wait, maybe not, because like you put maybe like the cabbage powder and all the other ingredients you put in, it's not just for the color. Like it might form a reaction again.
Okay, because what happens if I combine a base and an acid together? What do I get?
So
I get three things. I get water, a
substance.
salt, and lastly, what else do I also get? Oh, over there, the balloon experiment, I get a gas. So if I combine these two together, I should get water, a salt, which I won't really see, but I should get a gas. So we should see that in some way, shape, or form. All right, so let's combine these two together and see what happens. And 3, 2, 1. All right. So what happened?
A reaction.
We got a reaction. We got our gas. So we didn't add, like in this experiment, we didn't add the soap, so it didn't fuzz up like that. Instead, because the soap kind of slows the gas release down, and that's what makes the foam, but this time there was nothing holding it back. So that gas just came out. As soon as the reaction happened, the gas came out. Okay, and then we take a look, and what color is that?
Purple.
It's purple. It's similar in color to what it was before. So I know that we said that, well, if you combine a blue and a red, you're going to get a purple, and that is completely logical. But what has actually happened is we've neutralized our acid and our base. You see, our indicator said, oh, this is a base, I'm going to look blue. This is an acid, I'm going to look red. But when I combine the acid and the base together, I got water, I got gas, and I got a salt. And I should theoretically, if I put the equal amount, I have no more base and I have no more acid. So there is no more of that liquid saying, oh, you're going to be this color instead. So what's happened is this has just gone back to its normal color. I haven't combined two colors together. I've actually removed the thing that was causing them to be colors. Okay. So we have time for one more little thing, but it's actually a little bit outside of this science versus magic thing. Does anybody have any questions, thoughts, concerns about what we've done so far with our magic versus science? And if you, I can't see everybody, so
yeah, it turned pink, and why did it first turn pink and then it turned purple again?
Okay, so when I put my indicator color into the acid, that's a very good question, because I don't completely understand exactly what is happening on the physical level. But what is happening is when you see a color, that's because the light that's coming from up here, which is white more or less, it's not the same as the sun, but you have all the wavelengths combined, or at least most of them. When that hits an item, all but the color that you see is absorbed. So because it was purple, the greens are pulled in, the yellows and the greens and the yellows are going to be pulled out of that. They're going to be absorbed, and it's going to reflect the colors that you see. So blues and reds will combine to make purples, or just having a purple. When we do the reaction, what happens is it changes the absorption properties of this powder. So it no longer is absorbing all of the colors or emitting all the colors that it has left. So when it's emitting that red, what it's going is, it's now absorbing the blues and the purples it wasn't before. And it's only letting that red out. So it's keeping those other colors, it's allowing the red, but it's saying, oh, instead of just the yellow and the green, I'm also gonna hold on to the blue and the purple. Same thing that happens with our base. We're holding on to the reds and the purples, and we're only allowing the blues to come out. So it changes the reflective or the absorptive properties rather of those items. Okay. That would be something that you would definitely look into. Why does that color change actually take place? Very good question. Anybody else have any other questions before we move on to the next and last thing? Okay, so how many of you think that we have defied the laws of physics today, that we have done something that just does not compute, it doesn't work as far as what physics tells us? Okay. Because magic is a replacement for knowledge. That's something that you want to keep in mind, is that it's fun to make things up, it's fun to pretend, but at the end of it, if you're talking about something that is supernatural, you're saying that it exists outside of what we understand and know as science, as the laws of physics. So far, as far as every test that we have ever done, everything follows the laws of physics, and anything we don't understand, we know that it's just something we haven't learned yet. I'm sure you probably hear stuff about quantum mechanics. That's something that I only started learning about as a kid. It was new then, but now it's something that's very prevalent. There's even TV shows about that kind of stuff. So the last thing that I wanted to do was just something a little bit fun. And this is something, again, you can do this at home. If you wanted to do the color changing liquid one, you can buy this powder. It's not something you can find all over the place, but it's just red cabbage powder. And you can buy it online. You can probably find it in a store. And that allows you to do that. Okay? Everything else is stuff that you should be able to find in your home. So, this is just really fun. As I was talking about with matter, you have your solids, your liquids, your gases, and then your plasmas, which you either find in the sun, or if you happen to have fluorescent bulbs, that's actually a cold plasma, because it has to do with the electrons. We didn't really talk about molecules and atoms, but atoms are made up of 3 different particles. There's protons, neutrons, which are on the inside, and then the electrons on the outside. See, when you heat it up enough, when you put enough energy into an atom or a molecule, that electron just flies off and it leaves the atom, and then you just have this electron soup that's going on. So all the electrons are dissociated. They're still there, but they become dissociated from their atom, and that gives you the light. That's actually how light is emitted. And so we have a cold plasma. It's just you're putting electricity into it, which is causing that change in state, but the electrons quickly lose that energy, and as they lose the energy, they emit it in a form of light. The electricity goes back in, excites the electron, it moves up into a higher state of energy, and then when it moves back down to a lower state of energy, it emits light. And that's how it works. So this is a really fun and easy thing that you can do. All you need is some cornstarch and some conditioner. I recommend using a pleasant smelling conditioner. I happened to buy one that wasn't all that great smelling, and so it doesn't come across as well. All right. So to do this, it's just a kind of a ratio. So I'm going to put in 1 part conditioner. We're just going to measure this out. Onto my spoon here. All right, so I got a nice little heat, and we'll leave that in there to mix because it's definitely going to be messy. And I'll use this other spoon here to wipe it off. So I'm going to need 2 heaping spoonfuls of cornstarch. It's generally a 2 to 1. So you're going to have 1 part conditioner to 2 parts cornstarch. You'll probably need a little extra cornstarch just to make sure it's not too sticky. But we'll put in the 1, and we'll put in the second one. Okay, we'll leave that out just in case I need a little bit more. And then for added effect, what I like to do is you can either add color. So I got it right here. I normally don't. So add a little bit of color to it. And I'm also going to add a little bit of glitter. Kind of makes it pop. All right. And the white glitter doesn't show up as much, although it probably will show up a little more with the pink in there. I'll put put some silver in. And you know what? I want it to be a bright color, so let's go there. All right. Okay. Mix my items together. So what we're having is we have a kind of a gel-like liquid in our conditioner, and it's mixing together with our powder. So these are solids, but see, even though powders are solids, because it's multiple different little instances of small pieces, solid or powders tend to act like a liquid because those pieces can kind of run over each other. Just like the molecules of water. Okay, looks like I need just a little bit more conditioner. Once I've got it nice and mixed up, when all is said and done, I will have a cool little slime that I can use to stretch and play with. And slimes are really cool because they're like a liquid, but they're really, really viscous. So that viscous liquid holds its shape a little bit better than, say, water. And because of that, it allows you to kind of hold a liquid in your hand because it's kind of got some solid properties to it. And this is just the best slime. There's lots of different recipes, but this is a really simple 2-ingredient slime. Most of you should have this at home, and it's the softest and just the coolest to play with. It really has a nice texture and feel to it. It's also very, very messy. You can see my hand. And that's why I saved that to last. All right, my friends. So we've gone through a bunch of experiments. We've talked about what magic is and why we should at least theoretically think that the things that we've done today are not magic. They can all be defined by the laws of physics. I can look down, and if you understand the molecules and the atoms that are part of this, you can actually learn the math and find out why the things are occurring. I remember when I was in chemistry class in high school, they said organic chemistry was the hardest, and I imagine maybe at the college level it probably was, but I remember my eyes were opened. I learned a lot of chemistry up to the point, but when we got to organic chemistry, everything made sense. I'm like, oh, I know how these two things will react based on how I learned that this stuff will react. And that's the cool thing about science is, see, a lot of people will talk about prophecy, the idea of like being able to see into the future. Well, science kind of gives us the ability to be prophetic. Now, what I mean by that is when you learn enough about science, it allows you to understand things you don't, because you can go, well, if I know this and I know this, even though I don't know this, I can see how these two things are similar, and I can hypothesize, because you always want to test any hypothesis. Anytime you're guessing, anytime you're not sure, a hypothesis is a good place to start, but you want to test that, because a lot of times in science, if you have a hypothesis, you're like, that's just right, that just seems right. You find out that you're missing some little piece. It seems right, and it could be true enough without knowing, but that's actually not what's occurring. So you go through the scientific method, you learn everything, and you find out why things are the way that they are. So friends, I've run out of experiments today. If you have any more questions, by all means.
Bye.
All right, I guess there are no more questions. So thank you very much. That was
Thank you very much,
excellent.
everyone. You have been a wonderful audience. I've enjoyed every minute of it.
Bye.
Bye.
Bye, everyone.
Bye. Bye.